Okay, so a quick recap of electrolysis. Here are your syllabus statements. Covalent versus ionic. Here's some covalent molecules. They're covalently bonded together, non-metal, non-metal. The molecules have a fixed size. We've not got any ions present, so it can't conduct electricity. Here's our ionic substance. See the positive and negative ions, the grey positive and the blue negative. They're held together in that giant ionic lattice. The ions are fixed in place, and that means they can't move, which means it can't conduct electricity. We need mobile ions for it to conduct electricity. The ions need to be able to move. We can get them to move by either melting it and breaking those bonds, or dissolving it in water and breaking the bonds, which results in ions being able to move, so it conducts electricity. Here's a definition of an electrolyte. Simple definition. It's a solution simply that conducts electricity. First example that we're going to look at is sodium chloride solution, NaCl aqueous. Contains water and sodium chloride. Water, remember, dissociates a little. H2O dissociates a little to produce H plus and OH minus. Sodium chloride dissociates completely, splits into ions completely to form Na plus and Cl minus. We get 4 different ions in that solution. They're all mobile, they can move, which means it conducts electricity. Let's have a look at hydrochloric acid. Contains water and hydrogen chloride. Again, water dissociates a little to produce H plus and OH minus ions. Hydrogen chloride completely dissociates to produce H plus and Cl minus. So we get H plus ions here, OH minus and Cl minus ions. Let's have a look at electrolyzing molten lead-2 bromide. There's our setup to heat and electrolyze molten lead-2 bromide. It only conducts, remember, when it's molten, and then the light bulb lights up to show that the electrolyte is conducting electricity. We had a giant ionic lattice, we've melted it, so the lattice is broken, we've got these free ions, which means they can now conduct electricity. If we then apply a charge to our electrodes, we find that the ions are attracted to the oppositely charged electrode. So the Pb2 plus ions here are attracted to the negative electrode, and the Br minus ions here are attracted towards the positive electrode. Lead ions produce lead metal, bromide ions produces bromine. It's normally a liquid, but at this temperature, remember, we're heating it, it's going to be a gas. So produce lead metal and bromine gas. If we were to apply that information and try and electrolyze another molten salt, for example, sodium chloride, only conducts when it's molten, contains only sodium ions and chloride ions. Negative ions, chloride ions, are attracted towards the positive electrode, got to form chlorine gas. The positive ions are attracted towards the negative electrode, forming sodium metal. There they are. So sodium chloride produces sodium metal and chlorine gas when it's molten. Potassium chloride, exactly the same, only conducts when it's molten, K plus and Cl minus ions. Positive electrode attracts the Cl minus, producing chlorine gas. Negative electrode attracts the positive ions, K plus ions, producing potassium metal. There's your potassium metal and your chlorine gas. The last example is iron iodide. Only conducts when molten, contains Fe3 plus ions and I minus ions. The positive electrode attracts the iodide ions, forming iodine, and the negative electrode attracts the iron 3 ions, forming iron metal. There's the iron metal here, and there's your grey-black iodine. Bearing in mind it's molten, it's high temperature, this is likely to form a purple gas. It's likely to turn into a gas. Let's look at electrolyzing a dilute salt solution of an unreactive metal. Unreactive metals, the examples that I've given you are copper, silver, and gold. They've got to be lower in reactivity than the hydrogen. Remember that water dissociates to produce H plus and OH minus ions. So the first example we'll look at is copper 2 chloride. It contains Cu2 plus ions and Cl minus ions in solution. Remember, we've got the H plus and the OH minus from the water. The positive electrode attracts the Cl minus and the OH minus. It's a dilute solution. Because it's dilute, we've got loads of these OH minus ions, which means they react to form oxygen gas. Don't worry about how for the moment. The negative electrode attracts Cu2 plus and H plus. In this case, it's the Cu2 plus that reacts, and that's because copper is unreactive. So copper reacts to produce copper metal. So we end up producing oxygen gas and copper metal when we electrolyze dilute copper 2 chloride solution. Applying the same thinking to gold 2 iodide solution, we produce Au plus ions in solution and I minus ions in solution. We've still got the H plus and the OH minus from the water. Remember, it's in solution. The positive electrode attracts I minus and OH minus. It's a dilute solution. What reacts when it's a dilute solution? OH minus. It's dilute solution, so it forms oxygen gas. The negative electrode attracts Au plus and H plus. Because it's an unreactive metal, it's the metal that reacts, so you end up forming gold solid, which means that if you were to electrolyze gold to iodide, you would end up producing gold metal on the negative electrode. Let's look at a dilute salt solution, this time of a reactive metal. Reactive metals are higher than hydrogen in the reactivity series. The examples that I've got here: sodium, magnesium, iron, aluminium, calcium, potassium, lithium, all of those would be reactive. Water dissociates. Let's have a look at magnesium 2 chloride. Forms magnesium 2 plus ions and Cl minus ions. We've still got H plus and the OH minus from the water. The positive electrode attracts Cl minus and OH minus. Because it's a dilute solution, it's always the OH minus that reacts, so we form O2. This time, it's a negative electrode, attracts the Mg2 plus and the H plus. This time, it's a reactive metal. So here, it's the hydrogen ions that react, not the metal. When the hydrogen ions react, we form hydrogen gas. So we end up producing O2 at the positive electrode and H2 at the negative electrode. Iron 3 bromide, Fe3 plus and Br minus ions in solution. Water still produces H plus and OH minus. The positive electrode attracts Br minus and OH minus. Again, remember it's a dilute solution, so same here. OH minus reacts to produce oxygen gas. It's a reactive, relatively reactive metal. So although Fe3 plus and H plus are attracted, it's the H plus that reacts to form hydrogen gas. So again, we get O2 and H2 being produced at the positive and negative electrode respectively. Let's look now at a concentrated salt solution with an unreactive metal. There's my reminder of unreactive metals and my reminder about water dissociating. Copper 2 chloride contains copper ions and chloride ions. Water produces H plus and OH minus. The positive electrode attracts Cl minus and OH minus, but this time, because it's a concentrated solution, it's not the OH minus that reacts. It must be the Cl minus that reacts, and it produces Cl2. So you'd see chlorine gas, probably smell it as well, at the positive electrode. At the negative electrode, we've still got this battle between Cu2 plus and H plus. Bear in mind, copper is an unreactive metal. It's going to be the copper ions that react to form copper solid. So you'd see that pink-brown solid at the negative electrode appearing. Golds to iodide, again, very, very similar. Au plus and I minus ions. Water produces H plus and OH minus. Again, because it's a concentrated solution, it's the I minus rather than the OH minus that reacts, and that produces iodine. I've written there gas because it may evaporate sublime. It may be a solid that you see appearing. Negative electrode attracts Au plus and H plus, and again, because it's an unreactive metal, it's the Au plus that reacts to form gold solid in the solution, as it was before. Concentrated salt solution, this time it's for a reactive metal. There's my reminders. Magnesium chloride produces Mg plus 2 and Cl minus ions. Water produces H plus and OH minus. It's a concentrated solution, so it's the Cl minus that reacts to form chlorine. Negative electrode attracts Mg2 plus and H plus. It must be the H plus that reacts because the metals are above hydrogen in the reactivity series, forming hydrogen gas. So this time we get chlorine gas and hydrogen gas produced at the positive and negative electrode respectively. Iron 3 bromide. There we go, there are our ions. We've got H plus and OH minus. The positive electrode attracts Br minus and OH minus. It's concentrated this time, so it's the Br minus that reacts to form bromine. We've still got a reactive metal, so it must be H plus that reacts to form H2. Now here's the summary. Here's the bit that really pulls it all together. Cations, what are you looking for? Is the metal more reactive than hydrogen? If it is, then hydrogen ions react to form hydrogen. If the metal is less reactive than hydrogen, if it's not more reactive than hydrogen, it's the metal ions that react to form the metal. If you've got anions, we look at concentration rather than reactivity. The concentration, if it is a concentrated solution, it's going to be the non-metal ion that reacts. For example, chloride is going to produce chlorine. If it's not concentrated, if it's dilute, it's the OH minus that reacts to form oxygen. So there is your crucial summary of everything that we've covered just now.